Hi class, this is Math 110, section 3.4 and 3.5. We're going to talk about the derivative today. There are two different lines that we talk to that some go through the graph of an equation and some are tangent to the equation. Okay, so first we're going to look at the secant line that goes through the graph where x is -1. So that would be right here at -1, 3. Makes sense, right? When I put -1 in here, -1 squared, 1 plus 2 is 3. And 2, 6, because 2 squared is 4 plus 2 is 6. Okay, I'm just going to draw a very straight line. Okay, that's perfectly straight. That's the secant line through there. And we want the equation. So, of course, we need the slope. And we need the y-intercept. So the slope of this line is, I'm going to subtract the y-coordinates, which we said were 6 and 3. I'm going to subtract the x-coordinates, which were 2 and -1. It looks like we get 3 over 3. The slope of this line is 1, which looks about right, doesn't it? Okay, so the y-intercept looks like it's 4. I'm not, if I'm not sure, I might use the 0.26, use point slope form, y minus 6 equals slope times x minus 2, y minus 6 equals x minus 2. If I add 6 to the other side, I get y equals x plus 4. Okay, that's the equation of the secant line. But what we're going to be interested in with the derivative is the slope of the tangent line, or the derivative at x equals -1. So let's draw that one in red. Okay, the point -1, 3 again. If I would draw a line and it would just hit it once, just hit the graph right there at -1, 3. I like the equation of that line. So the first thing we need is the slope. Okay? So I can tell that slope's negative, can't you? It's going down from left to right. Okay, the slope of that line is going to be negative. I'm just not sure what it is. Okay, but luckily last class we learned that the slope of a tangent line is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so f of x plus h means I put x plus h right in here in for x. So instead of x squared plus 2, it's x plus h squared plus 2. And then I'm going to subtract the f function, which is x squared plus 2, and divide that by h. Okay, we're going to have to do a little algebra here. I'll scroll down a little bit. I'm going to get x squared. Oh, sorry, I lost my red. X squared plus 2xh plus h squared plus 2. Distribute my negative through here. Okay, so I just took x plus h and squared it. X plus h times x plus h is this. Let's see what cancels out. I have an x squared minus an x squared. I have a 2 minus a 2. So I'm left with 2xh plus h squared over h. I know I can take h into each of those terms. And it looks like I have the limit as h approaches 0 of 2xh. I'm sorry, just 2x, because I'm going to take the h out of there, okay? And I'm going to get 2x, and then h squared over h is just plus h. Well, when I approach 0, I'm letting h get smaller and smaller, closer and closer to 0. I can put 0 in for h here. I'm going to evaluate the limit, and I'm going to get 2x. Okay? So the equation of the tangent line at x equals -1 is 2 times -1, or -2. Okay? This, what I just found, is the slope of the tangent line anywhere on f of x equals x squared plus 2? I wanted it at -1. Okay, the point -1, 3. So my slope, since the slope is 2 times the x coordinate, the slope of this line right at -1 is 2 times -1 or -2. So now I can write the equation of the line. It's y minus 3 equals slope times x minus -1. If I want to write it in slope-intercept form, I'll have y equals, that would be -2x minus 2, but then I'll add the 3 over, so -2x plus 1. And if I think about the line -2x plus 1, it kind of looks like this is going to go through at 1, doesn't it, if I would have extended it? Okay, that looks like that's the equation of the tangent line at x equals -1. So we need the slope of the tangent line, and I found this formula for it. It's the derivative. It's the new word derivative. Derivative is the instantaneous rate of change of a function. Okay? And there we go. The derivative of a function is denoted. This is a new notation. Please make note of it. F prime of x is sort of how it's read. The notation f prime of x is read f prime of x. The function is called the derivative of f with respect to x. If x is a value in the domain of f, and if f prime of x exists, then f is said to be differentiable at x. The process of finding f prime is called differentiation, and that's what we just did. We just performed differentiation. This whole time you were practicing all the algebra involved with doing this was so that you could find the derivative of any function, which means that you have the instantaneous rate of change of a function at any given x. Okay, we've been doing the difference quotient. That'll give you the slope of a secant line, or the average rate of change, the average velocity, okay? Once you add this, the limit as h approaches 0. Now we're finding the slope of the tangent line, the instantaneous rate of change, instantaneous velocity, okay? So these are the types of things that you'll have in your homework. We give you an equation, and you're supposed to find f prime of x. Well, we just did, okay? We found f prime of x. It was x squared plus 2, okay? We found f prime of x back here, and we got it to be 2x, okay? That's what that's the new way they're gonna ask it. Instead of saying, hey, what's the slope of the tangent line? They'll say, find f prime of x. And we found it to be 2x by doing this on the previous page. Okay, so let's try with x cubed. All right, and I'm gonna take the limit as h approaches 0 of f of x plus h. So I'll have x plus h cubed minus 1. And then I'll subtract f of x and divide by h. Okay? Now, x plus h cubed is not fun. All right? Not gonna lie. That's I have to take x plus h times x plus h times x plus h. I know how to take the first two. I've done that on the previous page. X squared plus 2xh. We just FOIL. Plus h squared. That's x plus h times x plus h, but I have to multiply that again by another x plus h. So to do that, I take x squared times each term. That gives me x cubed plus x squared h. And then I take 2xh times each term. That gives me 2x squared h plus 2xh squared. And then I take h squared times each term. That gives me an xh squared, or h squared x, however you want to write it, plus h cubed. So I notice my like terms. I have 1x squared h and 2x squared h's. So it looks like I have 3x squared h's. Okay, I had my x cubed plus 3x squared h Well, these two are like terms. I have 3 of those, 3xh squareds, and then an h cubed. I'm going to subtract. Oh, whoops, I have to put the minus 1. And then I have minus x cubed plus 1. Minus x cubed plus 1. Okay, then that's, of course, all over h. We see what cancels here. Oh, I have x cubed minus x cubed. I have minus 1 plus 1. And now every term has an h in it, so I can take the h out of one of the h's out of each of these terms in the denominator, in the numerator. So I get 3x squared plus 3xh plus h squared. I don't have a denominator anymore, so I can put 0 in everywhere there's an h. So my final answer is just 3x squared. Okay? So I just kind of wanted you to look at the graph of this. If I look at x cubed minus 1, you can graph it on your graphing calculator, but it's the nice third degree polynomial going through -1. Okay, the derivative, or the instantaneous rate of change, we're saying is 3x squared. That is a quadratic. Okay, there's the graph of 3x squared. Always positive. Right? I'm never below the x-axis. And this, if you look at it, isn't the slope of the tangent line always going to be positive? Right? Always positive. That's kind of how they go together a little bit, okay? Just a little bit of checking out the graph as we go. The graph of the function versus the graph of the derivative. Okay, oh, I shouldn't have put that equals there. That doesn't equal that, I'm sorry. The derivative of x cubed minus 1 is 3x squared. Okay, let's try it with this function. Okay, I need to do the same thing. It's the same thing over and over. We're finding the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, every time. Now, minus a negative, let's just change that to plus. Okay, there's no sense having minus a negative. Our common denominator, okay, let's multiply top and bottom by the common denominator of xx plus h. Okay, I'm going to multiply the top and the bottom by xx plus h. When I do that, of course, the x plus h cancels here. So I have negative 2x. When I multiply this term by xx plus h, the x's cancel. So I have 2 times x plus h all over. I am just simply going to write the denominator. I'm going to put the denominator together. It's h times x plus h. Okay? We'll distribute the 2 through. That'll give me a 2x plus 2h. All over h, x plus h. Negative 2x plus 2x is nothing. Now the h will cancel here. So it looks like I have 2 over x plus h. Oh, it's just 2, right? Yes. 2 over x plus h. Okay, so this is my instantaneous rate of change anywhere on this function. All right? They're asking me to, so f prime of x is 2 over, oh, what? I forgot to take the limit. Geez, I'm wondering why that x is there. Why that h is there. I'm going to put 0 in for h. And we'll continue that on the next video.